Okay, so we're discussing factors affecting temperature of Pakistan. So we need to look at the climatic elements first of all. And the first climatic element is temperature, of course. So the climatic elements are all those elements that affect the climate of a particular region. Number one, it's temperature. Number two, it's rainfall. Number three is pressure and winds. Yeah, so we're going to be looking at these three climatic elements. And for temperature, I'm making this web so it's easier for you to understand how we're studying this chapter here. So for temperature, we'll be looking at the factors that affect temperature. For example, the first factor is latitudinal effect. The second factor is continental effect. Third factor is altitude. The fourth is cloud cover. The fifth one is angle of sun. So these are the five factors that basically affect the temperature. By changes in these factors, for example, if you increase the altitude, obviously that will affect the temperature. Cloud cover will affect the temperature of a particular region. Similarly, rainfall. For rainfall, we're going to be looking at the factors that cause rainfall, the types of rainfalls that basically affect the climates. Number one, monsoon rainfalls. We were talking about monsoon winds and monsoon rainfalls in yesterday's lecture. Now we're gonna talk about the monsoon rainfalls in detail. Western depressions. Number four, convection currents. Relief rainfall. And tropical cyclones. So these are all the reasons for the rainfalls in Pakistan. And we will be studying these. And pressure winds, it's just a complete topic on its own. We'll see the effect of pressure winds on the climate. So this is what we'll be covering here in this topic, the climatic elements. Let's start off with temperature. Let's discuss temperature in detail, the factors that affect temperature, the latitudinal effect first of all. So the latitudinal effect here is, so areas close to the equator, latitudes are all those, I remember in the first lecture, we talked about what the latitudes and longitudes are. So all those lines, the horizontal lines are basically the latitudes. So areas, I mean, equator is also a latitude, right? So this is, for example, the equator. So areas close to the equator, they receive direct sunlight, direct rays of sunlight. So temperature of those areas will be greater, okay? So you can say areas close to equator, direct sunlight, and because of that, those direct sun rays, those areas are hotter as compared to the other parts. For example, all the countries around this region, around this place, are hotter compared to the countries towards the north or towards the south. Also, for example, let's say if this is Pakistan here, so all the areas of Pakistan that are near this line, the southern parts of Pakistan are generally hotter than the northern parts of the country. Why? Because southern parts are around the equator. They're near to the equator. All right. So this is why, this is what the longitudinal effect is. All the areas near the equator will have warmer climates. Okay, number two, it is the continental effect. Continental effect is a term that describes the climates of those areas that are near the continents, near the seas. And obviously maritime influence isn't really, I mean, maritime influence doesn't work here. If you remember in previous lecture yesterday, I explained that maritime influence is the influence of sea on temperatures for all those areas that are along the coasts, right? The coastal areas. So what happens here is that the ocean currents, all those winds from the oceans, they have a moderating effect on temperature. And obviously this is why the summers are mild. So you can say continental effect is moderating effect ocean currents, and ocean currents are the winds prevailing from the sea. Altitude, on the other hand, is the relationship between the increase in height of land and the temperatures. We know that the air is densest at the sea level because it has the most moisture. So the coastal areas, the air around the coastal areas has greater density as compared to the air on the highland areas. Why? Because the air is densest near the sea because of the level of moisture. Air absorbs moisture, right? So obviously around the sea, it will have the greatest moisture content. This is why the density of air will increase. Similarly, it will decrease at higher altitudes. So you can say that air is less dense at high altitudes, and because of that, the temperature drops 6.5 degrees Celsius drop in temperature each 1,000 meter. So as you ascend 1,000 meter, your temperature will drop by 6.5 degrees Celsius. And then let's say you climb up another 1,000 meter, your temperature will drop 6.5 degrees Celsius even further, right? This is how the temperature drops as the altitude increases. There's a negative, there is an inverse relationship between altitude and temperature. Cloud cover. So cloud cover basically affects the radiation and reflection of heat. What is radiation? Radiation is basically the heat that is exerted from the earth. This is the surface of earth. So first of all, the sun rays will heat the surface of earth, and a reverse process will be that the trapped heat would also radiate back to the sky. And let's say if there is a cloud cover on a particular day, those clouds will form a layer, not letting the heat enter the earth or the heat of earth exit the atmosphere. So this particular factor, cloud cover, affects the temperatures separately during the day and at night. So whenever there is a cloud cover, days are cooler and nights are warmer. Why is that so? Because the radiation takes place at night. You need to know that radiation at night. So because the earth radiates heat energy at night, and this cloud cover will not let that heat go outside of that particular area or the atmosphere, that heat would continue to be trapped inside and it will cause the temperature of the earth to rise. This is why on a particular day of cloud cover, you'll experience that the temperature at night would be warmer. It would be greater as compared to the temperature during the day. And during the day, because of cloud cover, the heat wouldn't enter the atmosphere of Earth. And this is why the days are cooler. Is this clear up till now?
Yeah.
Okay. We're now studying latitude and angle of sun. So angle of sun also has its effect on temperature here. This angle refers to the position of Earth in relation to the sun. So Earth's position in relation to the sun. So what happens here is it's pretty similar to latitudinal effect, all the areas that receive direct sunlight will be warmer, and all the areas that receive indirect sunlight will be colder. So if I, let's say, draw a diagram here, so, and imagine this is where the rays are coming from, the sun rays. All the areas over here, this region here, the red region will be warmer. And because the rays have to travel a greater distance to basically travel towards the north and the south, so these areas will be relatively cooler, the ones in blue here. So what you can say is that these areas are at low angle of sun, and because of that low angle, the distance is longer. So long distance between the sun rays and the the actual part of the earth, and this part over here has a high angle, and because of the high angle, the distance is shorter. It's easier for the rays to reach at that point. All right, so this is what the angle of sun is. These are all the factors that affect temperature, and temperature is a climatic element that in turn affects the climate of a particular area. You can note the things down. You can either take a screenshot of this part of the board here.
Can you zoom out just a little bit more so I can see the whole thing?
Yeah.
Okay, I've done it.
Rainfall now. We're now discussing rainfall here. First type of rainfall is due to the monsoon winds. This word monsoon means season, seasonal winds. So we're talking about a particular season of rainfall. Okay, so monsoon winds blow during summer and in winters. So the summer monsoon are known as the southwest monsoons. They blow from the southwestern regions. And the winter monsoons are known as the northeast monsoons, northeastern direction. Okay, so what happens is that in summers, these monsoons, they blow from the sea towards the land. These summer monsoon winds, they blow from sea to land, and the winter monsoon, the northeast monsoon winds blow from land to land to sea, sorry. An example could be, for example, okay, let's just also note down the areas. If we talk about the summer monsoon winds, just a second. Okay, the southwest monsoon. So these winds, they basically originate from the Arabian Sea, and they travel towards the Indus Delta from the Bay of Bengal towards the Indus Delta, and they also, I mean, they also enter India, because obviously India is a neighboring country. So all of these areas of Bangladesh, India, Pakistan, they're affected because of these winds. The northeastern monsoons that blow in winters from land to sea, they travel Okay, so now their path is exactly the opposite of the summer monsoons. They travel from the Bay of Bengal, Bangladesh, India, and then to northern Pakistan. So okay, so another thing that's common about these winter monsoon winds is that only the tail end of these winds reaches Pakistan. So tail end reaches northern Pakistan. Okay, only the tail end. Why? Because most of the monsoon are basically traveling from the land to sea, so they'll basically blow over the Arabian Sea. Only only some part of those winds will basically travel to northern Pakistan. The winds that will be deflected from that particular area, from the Bay of Bengal. Okay, so this is the difference there. And obviously they cause heavy rainfall. This is you could say an identification of monsoon rainfalls. Uh, Heavy rainfalls accompanied by thunderstorms. Okay. Now we're looking at the Western depressions. The Western depressions are basically cyclones that originate in the Mediterranean Sea. They travel from Afghanistan to Iran and then to Western Pakistan. All right, so this is the path of Western depressions. That's it. The third one are convectional currents. Convectional currents are also a cause of rainfall here. So I'm assuming that you're aware of the process of convectional currents. If you've studied physics before, the land gets heated up, the air rises because of the lesser density, and that particular area is replaced by cool air. All right, and condensation occurs and then precipitation. Okay, so hot air rises, condenses, and precipitates. So this is what convectional current is. And convectional currents, they can also cause strong winds or thunderstorms. Thunderstorms and let's move. I think, yeah, that's it. Let's move on to the next point here. Relief rainfall. Relief rainfall is a typical feature of rainfall of the highland areas, basically. So what happens is that it involves the rising of a flare from one side of air from one side of the mountain, and it rains on the other side. So I'm going to explain this with the help of a diagram here. For example, if this is a hilly area and here's all the water, so the air would rise up from one side. This is known as the windward side, and this is known as the leeward side. So leeward side. This leeward side is also known as a rain shadow area. There's no rain on this patch here, and this is where the precipitation occurs, and it usually rains on this windward side here, and this is the condensation level. And you can say that this rainfall is experienced by higher altitude areas. For example, Murray, Chitral. And this obviously this rain shadow area, this leeward side is typically dry because of lesser rainfall. And this is one of the features of that area. You'll see barren mountains, lack of vegetation, I mean, because of lack of water. Whereas the rain shadow area, sorry, whereas the windward side is usually green, full of vegetation because of adequate rainfall and water supply, right? Now, the fifth part, or the fifth type of rainfall is tropical cyclones, the rainfall caused by the tropical cyclones. Tropical cyclones have, they're known for bringing destructive winds, heavy rainfall. And they originate over the Arabian Sea. And they reach these coastal areas of Pakistan. And you'll experience tropical cyclones wherever you go all across the world, on the coastal areas. It's not just Pakistan, but it's a typical feature of every coastal area around the world, because obviously the oceans, the seas, they generate these destructive winds, and they travel to land, and then they cause heavy rainfall. We are done with these 5 types of rainfalls as well. I'm going to zoom it out here if you want to take a screenshot, but I'd really prefer if you write the things down side by side. It also affects your understanding. Let me know if there's any questions so far.
Could you zoom out a bit more?
Is it readable? Is it still readable?
Yeah, yes.
Okay.
Okay, I've done it.
Okay. Now let's talk about the last climatic element, pressure and winds. Okay, so pressure and winds, they work together to create a specific climate of a certain region. So if we just look at the examples here, the central Pakistan has a higher temperature generally because the air over there rises up. I mean, obviously the air is hotter and that air rises up. So what you can say is that in summer season, air rises. We're talking about the central Pakistan here. And when that air rises, it creates a low pressure zone. Okay, what happens is that this low pressure zone is then replaced by the air coming from the oceans, because that air is relatively cooler at low temperature, and obviously it will have greater density. it will fill up the spaces. So air from the oceans fill up the space created over the land. And this is how the winds travel from one area to the other. There's a difference of pressure, and the difference of pressure is basically covered through these winds. Let's say, for example, this is the part of the land where the winds, sorry, let's just mark it with red, where the air rises up, okay? And because let's say this is the part where a space is created, this green dotted line here, this is a temporary space that's been created, or you could say this is the low pressure zone. Now this is, for example, sea here, and the airs, because the air of the sea is relatively cooler because of the greater density, it will then travel and it will take place this area here. So this is how the space is full, it's filled with this cooler, and obviously this wind brings up the rainfall as well. This is how the winds generally travel from one place to the other because of the difference in pressures. And this is how these winds, they carry, they basically carry rainfall as well. In winters, the situation is reversed. This entire concept is reversed in winters. Reversed process. Generally, the land is cooler, and the seas are hotter. So this low pressure zone is created over the seas in winters. You can say that low pressure created overseas. All right, and then in those cold airs, the cold winds from the land, they flow towards the sea, they fill up that pressure, and they carry the rainfall. This is what pressure and winds was. I'm going to zoom it out again. And here we're done with this topic as well. The climatic elements. This is all. From the next lecture, we will be talking about the effectiveness of rainfall and how all of these climatic elements, or all these climates, they affect the particular areas of Pakistan: highland, lowland, arid, semi-arid, coastal climate. So this is what we're going to study in the next topic: the effect of these rainfalls, or the effect of all of these climatic elements in general on these areas of Pakistan.